Hello, I'm Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IBM Europe. In this movie, we're going to look at the new AIX6 feature called the encrypted file system. First, a few important things we need to learn first. Firstly, the encrypted file system isn't actually a new file system. It's a feature of the JFS2 file system that we've been using for quite a few years now. So we get all the inherited benefits of that, like logging disk changes and being able to change the size of the file system on the fly. Now we can either create a new file system which has this encryption, or we can enable it on an existing JFS2 file system. But we can't enable it on some, the important file systems like the top level file system slash or user var and opt. So this is for encrypting your data files, not for actually encrypting the operating itself. Now we can make all files in a file system secure. We switch on a feature called inheritance, and all things created in that file system will then be encrypted. Or we could make, if we've only got a handful of files, we could just encrypt those important files to keep that data safe. To access the data, we have to use a key store, and to access that we need a password. Now that can be connected to your login password, so when you log in you'll pick up your keys. Or you could use a different password, and it's this feature that enables you to not give root access to your key store, and so the root user cannot actually access this data. It's an important point and a very high security feature of our encrypted file system. Now let's turn our attention to the prerequisites if we want to use encrypted file systems. First, note that the use of a secure network environment is more important than an encrypted file system. If you haven't got a secure network, if you're still using things like Telnet and FTP, which are a hacker's delight, then there's no point in having an encrypted file system. Only if all your users are accessing the particular machine via things like SSH or secure FTP, or a encrypted method inside the application when it's talking to the server, is there any point in using an encrypted file system. Next, we have to have RBAC switched on. This is part of AIX6 and on by default, but here's the two commands to check that it is enabled and switch it on if necessary. We also need this crypto-like C library, and that's on the expansion pack. We simply install that. And fourthly, we use this EFS enable command to switch on our encryption. Okay, we'll run the lsatra command there. We see enhanced rollback is true, so that's switched on our machine. I've pulled out the click package out of the expansion pack, and I'm going to run inutoc to create a .toc. An important point there is on AX6, I believe the output and what goes into the toc file is different to AX5, and so if you're installing onto an AX machine, you have to run that actually on the AX6 machine itself. Let's go and run that and install it. There we go, they've got the libraries there. Okay, that all worked fine. Now we can see it's all installed. And we'll switch it on with EFS enable. That's it. It's asking us here for a password to access the key store, and I don't want to make that the same as the password that I log into for extra security. At this point, it's creating a whole load of directories that will hold the key stores and the information and log files. Takes a little time. There we go. The information is actually stored into var EFS. See some directories in here with all the information in it. Now let's create a new file system with this enabled. Add a file system, root.vg, 1 GB, let's immediately put the mount point in here. Read down to the bottom. Enable EFS. Yes. Or we can go here and I can just run this command, create fs, and do much the same sort of thing. Actually got the size wrong. 1 gig. And I'll mount it up. And if we use ls file system minus q on, we'll see here that it's split over the line. EFS equals yes. So this is encrypted file system, and we could use the other good things like the inline logs and the snapshots. This is just a regular JFS2 file system. Now the next thing I want to do is run this command here, EFS manager, and we're going to set inheritance on for this particular file system so that all files in this file system will be encrypted. Okay. Now let's do some simple operations on our new file system here, /secret. I want to create a file here and put it into the hello file. And I want to provide a negative test before we do a positive test. Anybody watched Blade Runner recently? Anyway, there we go. I'm going to create a file, and it says no. We haven't got a security attribute that would allow us to do that. Well, let's go and get one. EFS key manager minus O, and I'm going to run this corn shell with my new permissions. It's going to ask me my password. Of course, let's hope I can remember that. And we're in. If we check PS, we see we've got an extra corn shell running here. So let's run our command again. Works just fine. Gonna have a look at that file. There it is. There's another one I created earlier. The hello file. We can cat that file. Everything's working fine. And then if I Control C and come out of that, or exit out of our corn shell, back to the original. If I try and run that command again, I can't actually open that file at all. Also, I've got a regular user here called NAG, and he's going to look at that, try and look at that file as well. You can see it there. I've actually named the particular file, that's why we don't see that high file. And let's try and VI that file. You can see we've got read access to the directory and the file itself. So file permissions are not an issue. There it says, can't find the requested security attribute. So root has created a file here that's encrypted and we can't see the data as a user. Now let's take an example from the banking industry where security is always important. The bank manager wants access to some secret information. Perhaps it's something that needs to be kept very confidential, like account information. Yet the bank manager wants to be able to read that file simply enough and wants to be able to update that as more information arrives. But we don't want the super user, the root, the operator, the systems administrator, whatever you want to call them, to have access to that data. We don't want to read it or be able to modify it at all. And yet we still want them probably to back up the file. We don't want the bank manager to back up the files using his own procedure. Now, as you see at the top here, I've emptied our secret file system, and I've created a user called Debbie, who is the bank manager, and I just want to have a look at the characteristics for that AX or Unix account. Okay, just a regular account in here, but if we go down to the bottom, we can see there's lots and lots of password administration features here. Confess I don't know what most of them do. At the bottom we have these 5 new fields in here. We have an entry for how we're going to access the key store, and the administrative key store. We have the initial key store mode, and we're going to go for root guard mode. This stops the root user from accessing our files. And we can say whether the user is allowed to change this mode or not. At the bottom here we have lots of different algorithms that we can set, 6 different algorithms, and that allows us to trade off more and more complicated encryption. That of course will take a little bit more CPU time to encrypt and decrypt our files as we go. As I said, we've already created this user, so let's log in. I'll turn that in as a regular user. Log in as a administrator here. We've already set the password up as before. Nothing strange there. Now I want to get Debbie to create a file that's encrypted in our file system. And so here I've just echoed some words and put them into a file called meaning. Now that might not be what you are quite expecting, and it certainly caught me out the first time. By default, regular users, when they log in and give their password, they also get access to their encrypted file system certificates. So the default is that they can then immediately read and write their own private files in the secret file system. Now in our case we want to stop that happening because the root user can SU into the Debbie account. They too can gain access to the encrypted file system certificates. So we have to break this link between the AOX Unix password and the encrypted file system password. And we do that by giving ourselves a different password for our encrypted file system keys. And we use the EFS key manager command with -n, perhaps that's for a new password. It's asking us for our current password, which by default is my login password. So I'll type that in there now. Now we're asking for this new password for our key store, so we can keep these two things separate. The root user, of course, will have access to my Unix password, but won't have access to what I type in here now. So let's just type in a quick password. And a mismatch. I didn't type it accurately enough. There we go. Now we'll come out of here and we'll re-log in as a user here. AOX password, and we're in. This time, if I rerun the echo command in here, I haven't yet got my encrypted file system keys or certificates. So this will fail. And if I was the root user, I'd have failed here to actually create a new file or even edit that file. Now, if I want to actually gain access to my secret data again, I have to use the same command as we did before, -o to give us a new program that does have access to this. Of course, this could be some other program, not just the shell. And it's asking us for this new password that we set on our extended encrypted file system certificates. And I'll type that in now. Okay, let's run that echo command again. And that works fine. And we can cat that back. For example, just we know it's there and accessible to us. If we now go as the root user and we SU to Debbie, can we gain access to that file? Let's do a quick cut and paste. No, the root user cannot access the Debbie user's secret files unless he knows that password. So how do we back up our important data in our encrypted file systems in a safe way? Well, the golden rule is we must never put unencrypted copies of these files into the backup tape. It's well-known stories in the industry of tapes falling off the back of a van, or the tapes get old and they're sold off, and somebody buys the tape with loads of data and they go and have a look through it. So we must put encrypted versions of these files onto the tape. But then we have a problem here, don't we? If the root user doesn't have access to the files, they can't actually open them, we just saw that, then how are they going to back them up? And if you're the user that has the password, when you read through the file, it's unencrypted and in clear text, so you can't back it up either. So what we have is these four tools have been enhanced to backup of encrypted data. There's the backup and restore, tar packs, and CPIO. And all of them have a minus capital Z option, and this says we'll actually do the backup operation, but instead of giving you the clear text as you're reading through the file, you'll actually go and read the raw encrypted version of the data and put that into the backup for you. This means you actually create a new file or an archive, but the files in that are encrypted, and without knowing the password, you'll never be able to unencrypt that file, no matter who gets hold of it later on. Now you could get the key store password, the key holder, in our example here, the bank manager, to do the backups, but I don't think they're going to be very keen to do that at 3 o'clock in the morning. So we can also get the bank manager type person, or the person with the password, to actually archive the important files and put them into a regular file system. Then the administrator can pick up those encrypted files whenever they're actually doing the backup, perhaps late at night. So let's just give you a little example of the backup then. We're still the Debbie user here and have access to this file. We can use the tar command here to create an archive. The single file it's going to back up here is secret meaning, and it's going to put it into /temp/backup unsafe.tar. Not going to take very long, as you expect. It's only a little file. If we then put Z in here, and we'll make this one called safe. We'll see it's a bit bigger because it stores a lot of credentials actually in the file. I should make it clear also that to get that data back, you also need the key store, not just the password, to actually get the data back. And so it is important for us also to back up the key store. Okay, so if we change to that directory, we find we have two files in here, and let's try something that's slightly dangerous. If we cat the unsafe tar, we'll have some gibberish on the front to then the actual data. Okay, so this is the tar information in here, the file name for example, and we can actually see the contents of the file just straight into that image there. If we have a look at the safe version, we're going to get some ghastly things. Oh, we survived, okay. In there was nothing of any importance, but we could grep for universin. So to see if we can find, no, we can't find any of the words probably in here. So where is the key store? We had a look at that very briefly earlier on. It's all in a directory called /var/EFS, and for a particular user there's a subdirectory called users and the actual username, in our case Debbie, and there's a file called key store, and this is an encrypted binary file. So we can back them up, they're not very large, but we need to do that along with the backup of any encrypted data, otherwise we cannot open that data later on. So let's have a quick reminder. Encrypted file systems for AIX6 and above, so secure that not even root can access your data files. A very tricky thing to do with standard Unix. Don't forget to back up those key stores if you want to be able to recover your data from your backup. And remember that without a secure network, this is largely pointless. You really need to stop people listening to what's going on over your network anyway. There's a lot more in here besides that we haven't had time to cover. We can do things like encrypting single files. There's lots of things we can do with the management of the key store, changing the size and the algorithms on the fly. And we can examine our keys and age our keys in our key store. There's also a lot of stuff about private and public key and integrating those with a certificate infrastructure so that you can remotely access your files without having to type in your passwords. If you want more information, the place to go is, of course, one of our red books, and here it is. You can look at the details. Also, if you want to have a bit more details of the commands we've been using, there they are. The EFS Manager and the VS Key Manager is the first place to look.